In the next couple lessons, we're going to look at division of polynomials. And before we get started with actual division, we're going to look at some rules from factoring. And this is just a review. So if I look at the difference of perfect squares, simple case, if I have a number squared minus another number squared, all right, so what we want to do here is break it down so that I have two polynomials or binomials that multiply together to get this. So I have x times x is x squared, and I know a times a is a squared, but for that middle term to go away, I'm going to have an x plus an a and an x minus an a. Okay, so real quick example, how about if I have x squared minus 25. You know, both of these are perfect squares, and I want to break these down so I know x times x is x squared, and then 5 times 5 is 25, so that would be my a value. That's the number that's squared, and then one of these has to be positive and one of them is negative. So in the next part, I have squares of binomials. So that means I have x plus a number, and I'm going to square that. Most of the time, or many times I should say, when we do this, we think, okay, we're going to square the first term, so I'm going to square x. I'm going to square a, but we forget about the middle term. So if I were to multiply x plus a times x plus a, I'm going to have x squared plus ax plus another ax. So I'm going to have two of these middle terms. So that's always depending what a is going to be. I'm going to multiply these two numbers together and multiply it by 2. Same thing here. We square the first term, we square the last term, but that middle term, now I have negative a times x is negative ax. So I'm going to have minus 2ax plus a squared. So then we have perfect cubes, just like we have perfect squares. And if I were to square a cube, that would be saying I want to multiply x plus a times x plus a plus x plus a. And it's always going to follow this pattern where I'm going to end up with x to the third power, and then I'm going to have plus 3x squared times whatever a is. Now this is going to be most likely a number, so we would have to multiply that by 3, and then we would have our coefficient times x squared, and then we're going to have 3x times a squared, and a squared would be a number, whatever this is, and then times 3, and then plus a to the third power. If I am multiplying the difference, I have a cube and I'm multiplying this to the third power, I'm going to have x to the third minus 3x squared a plus 3xa squared, and then a minus a to the third power here. So if I just try this, let's do an x plus 2 squared. Sorry, third power. So I'm going to have x to the third, and then I'm going to have 3 times a, which is 2, so that would be 3 times 2 is 6, x squared, and then I'm going to have 3 times a squared times x. Well, a squared is 4, times 3 is 12, x, and then plus, I'm using this top one up here because it's plus, 2 to the third power is 8. Okay, so that was a lot easier than using FOIL on that one multiple times. Then I have the difference of two cubes. All right, so if each of these numbers are cubed and I want to factor this, I'm going to get a binomial which if it's the difference of cubes, I'm going to get x minus a, and then I'm going to multiply it by a trinomial. And then inside the trinomial, I'm going to have x squared plus ax plus a squared. If it's the sum of my cubes here, I'm going to have x plus a, and then my trinomial will be x squared minus ax plus a squared. So a couple things here. If I start with a difference, my binomial will be different, and this term right here is going to be the opposite. In both of these, that works. I start with the binomial has the sign of our problem, and then inside my trinomial, the second term has the opposite sign. So if I do just a real quick example here, if I think of cubes, how about if I do x to the third plus, what's a good cube number, 27. So x is to the third power and 3 is to the third power. So 3 is my a value. So in my factoring, I'm going to have a binomial with an x plus 3, and then I'm going to have x squared minus a times x, so minus 3x, and then plus a squared, so that'd be plus 9. All right, so these are just some rules of factoring that we haven't really talked about yet, but they're going to be helpful for the rest of this whole unit, not just today's lesson. So then what we're going to do is we're going to work with some long divisions. We're going to get to polynomials, but I just want to think about the process that we used back in 5th grade when we were learning how to divide. Since I'm dividing by 15, that's going to be the number that goes into 842. All right, so I rewrite my problem. This is long division. The first thing I would do is estimate. So 15 goes into 84. 15 times 5 is 75. So that's the closest estimate I can get. So the first step I'm going to do is estimate. And we're not going to do these other two problems here. I think one will be good enough. So after I determine how many times will 15 go into 84, then I need to multiply. So I'm going to multiply. 5 times 15 is 75. My next step would be to subtract. So if I subtract 84 minus 70 is 9. And then the last thing I would do is bring down the 2. So 15 would go into 92. So number 4 would be bring down. The next number, 15 goes into 92 6 times. So I'm starting the process back again. As long as I have numbers here to bring down, I will repeat this process. I estimate 6 times, then I'm going to multiply. 6 times 15 is 90. I'll subtract, and I get 2. So we, in 5th grade, learned to say, okay, my answer is 56 and remainder 2. And another way to say this is I have 56 and I have plus 2 over the number I'm dividing by, so plus 2 over 15. Or I could write this as a decimal if I want to keep on bringing down my decimal values. So in the next example, we're going to divide polynomials. All right, so if I look at example 2, I have a polynomial here, and I'm going to divide by x squared plus 1. So I'm going to take x squared plus 1 and write that as on the outside as a number I'm dividing by. And inside the division sign, I'm going to have 3x to the third plus 4x squared plus x plus 7. All right, so if we repeat our process, remember 1 was estimate, 2 was multiply, 3 was subtract, and 4 was bring down. Okay, so we're going to use those steps. So I'm going to estimate how many times x squared will go into 3x to the third power. Or I'm going to say, okay, what would I multiply x squared by to get 3x to the third power? And that would be 3x. So that's what I'm estimating. So now I'm going to multiply 3x times this binomial. So 3x times x squared is 3x to the third power. And 3x times 1 is 3x. Now when I put these down here, I want to make sure that I'm lining up my terms. So 3x times 1 is 3x. This is my column for x squareds. So I'm going to put my 3x under the column for the x's. So I multiplied. Now I need to subtract. And I'm subtracting all of this that I had multiplied. So I'm going to subtract 3x squared minus, or 3x cubed minus 3x cubed, and that's going to cancel. I have no 4x squared, so I can put a plus 0 x squared, and I'm still going to subtract here. So I have 4x squared minus 0 is 4x squared. And then I have 1x minus 3x would be negative 2x. And then I'm going to bring down my 7 plus 7. So I multiplied, subtract, I brought the next number down, and now I'm going to go back and repeat. So now I'm going to estimate how many times x squared goes into 4x squared. And that would be 4 times, because 4 times x squared is 4x squared. So that would be a plus 4. And I multiply, 4 times x squared is 4x squared, and then 4 times 1 is 4. So I have a plus 4 here. I'm going to subtract this whole quantity. My 4x squared minus 4x squared are going to cancel. I have minus 2x minus nothing, so that's minus 2x. And 7 minus 4 is positive 3. So I don't have any other numbers to bring down, so this part right here is my remainder. So my answer, I would say I have 3x plus 4, remainder negative 2x plus 3. And we're going to write this as a fraction. So I'm going to say I have plus negative 2x plus 3 over my divisor, which is x squared plus 1. All right, so it asks us to check our answer. So what we need to do is take this part of our answer and multiply it by what I divided by. So I'm going to have 3x plus 4 times x squared plus 1, and then I'm going to add negative 2x plus 3 when I'm done. So if I distribute, here's my check, 3x times x squared is 3x to the third. 3x times 1 is plus 3x. 4 times x squared, and then 4 times 1 is 4. And then I'm going to put this in order of exponents going down, so I'm going to have 3x to the third plus 4x squared plus 3x plus 4. And I'm going to subtract 2x here. Oops, sorry. Subtract 2x here. And 3x minus 2x is 1x. And then 4 plus 3, I'm going to add 3 here, will give me 7. So 3x to the third plus 4x squared. 3 minus 2 is 1x, and 4 plus 3 is 7. So this is just checking our answer, and I'm not going to ask you to do that. I just wanted to show you how that works. In example 3, we're going to divide again. This time we're dividing by a trinomial, x squared minus x plus 1 divided into x to the fourth minus 3x to the third. And then look here, I kind of jumped a variable. I don't have any x squared term in here. I need to hold that place with a 0. So I can say 4, 3, I can say have, whoops, this was a 3, that's why I was looking weird here. So 0x squared plus 2x minus 5. So this is kind of like saying if I had the number 107, I would put the 1 in the hundreds place and the 7 in the ones place, but I have to hold that tens place with a 0. Okay, I just can't write 1 and 7. I have to hold the tens place, and that's the same thing with our x squared place. All right, so following our steps, the first thing is to estimate. And we're just going to take this first term and ask ourselves, what do I multiply x squared by to get x to the fourth? And I know that's x squared. X squared times x squared is x to the fourth minus x to the third. And then x squared times 1 is plus positive x squared. Plus 1x squared. Now I'm subtracting this entire quantity, and I think the most common mistakes come from the subtraction part and not keeping track of our negatives, because here I have negative 3x to the third power minus 1x to the third power. Sorry. Negative 3 minus negative 1. So it helps you to write over to the side, negative 3 minus negative 1 is negative 2, x to the third. Then I'm subtracting 0 minus 1 is 1, and that's negative 1, x squared. 0 minus 1 is negative 1. And then I've done my subtracting. I'm going to bring my next number down. So in the next part, I'm going to estimate how many times x squared goes into negative 2x to the third, or what do I multiply by to get this? And I would multiply by negative 2 and x. So negative 2 and x. Now I'm going to multiply negative 2x to the third. Negative 2x times negative 1x is plus 2. 2 times 1 is 2, x squared. And negative 2x times positive 1 is minus 2x. Now I'm subtracting. So I have negative 2x to the third minus negative 2. Subtracting the same thing, they cancel. Now I have negative 1 minus 2 is negative 3x squared. And 2x minus negative 2x is positive 4x. And I'll bring down the 5. Minus 5. So I have one more time. X squared times what number is negative 3x squared? That would be negative 3. Multiply, I get negative 3x squared. Negative 3 times negative 1 would be positive 3 with an x. And negative 3 times positive 1 is minus 3. Now when I subtract, first term cancels. I have 4 minus 3 is 1x, and negative 5 minus negative 3 is negative 2, or minus 2. So my answer here is going to be x squared minus 2x minus 3 with a remainder. So I'm going to add a remainder written as a fraction. So I'm going to add the remainder, which is x minus 2, over what I divided by, which is x squared minus x plus 1. All right, moving on. Do a couple more. Example 4, we are taking x squared and dividing it into, x squared goes into, sorry, I just dropped my pen, 3x to the third minus x squared. So let me check my exponents. 3, 2, 1, 0. So I don't have to hold a place here. 3x to the third minus x squared plus x minus 2. So I'm going to estimate or ask, what do I multiply x squared by to get 3x to the third? That would be 3x. So 3x times x squared is 3x to the third. Now I'm going to subtract. They cancel. I bring down my next number. So I'm going to bring down my minus x squared. X squared times 1 is negative 1 is minus x squared. So I'm going to put a minus 1 here. Negative 1 times x squared is negative x squared. When I subtract this, I get 0. I'll bring down my x and my minus 2, and x squared won't go into x. So this is my remainder. So if I write my answer, I have 3x minus 1 plus the remainder, x minus 2 over what I'm dividing by, x squared. So this is my answer. And the very last one, I am dividing by 3x to the third minus 1. That's going into x to the fifth. Oh, so I have some spaces here that I am not accounting for. So I'm going to start with 3x to the fifth. I don't have any x to the fourths or x to the thirds, so I'm going to hold those spaces. 0 x to the fourth plus 0 x to the third minus x squared plus x minus 2. All right, so I got to make sure, because these terms aren't in here, I still have to hold their place. So now I'm going to multiply, or ask myself what I do multiply by. Here I have 3x to the third. I need to multiply by x squared. So x squared, I have 3x to the fifth. And then minus, now this minus is x squared. So I'm going to go minus x squared right over here. All right, so the 3x to the fifth subtracts to be 0. I have no x to the fourths or x to the thirds. I have minus x squared minus x squared, so that's 0. And I'm going to bring down my x minus 2. So in this case, My 3x to the third does not go into x, so this is my remainder. And my answer will be x squared plus x minus 2 over 3x to the third minus 1. And that's it.